Okay folks, so today's video is on polymers. What are they and what are their properties and uses? So we're going to start off as always with a quick quiz. So if you want to pause the video and then have a go at these questions. So I'll give you 5 seconds and then we will go through them. So 5, 4, 3, 2, 1. Okay, so if you haven't finished yet, pause it and do them. Otherwise, let's go through these. What is the functional group of the alkene homologous series? So the functional group of the alkene homologous series is carbon double bonded to carbon. If you can hear some crinkling stuff in the background, it's because I'm recording this in the kitchen at the same time as my wife's cooking dinner for the kids. Lockdown life. Right. Draw a molecule of ethene. So you should be able to work out that eth means 2 and ene means it's an alkene. And we've just said alkenes have got C double bond C. So eth, 2 carbons. So we need 2 carbons with a double bond. And then we need to fill the rest in with hydrogens. Okay, so propene, same thing. Pro means it's got 3. Ene, it's going to have a double bond on one of them. So 3 carbons, one of them's got a double bond. Let's fill in the rest. It needs 4 bonds. It's got 1, 2, so 3, 4. This one has already got 3 bonds, so we'll add in a hydrogen. Doesn't matter if you put it at the top or bottom. This one's got 1, so we need 3 hydrogens. 1, 2, 3. Right, what does unsaturated mean? So unsaturated means it contains a double bond. So if we look, so double bond between carbons, right? So these are all unsaturated because they're all alkenes. Alkenes are unsaturated. Describe a test to see if a hydrocarbon is saturated or unsaturated. So if you remember, saturated, there's no double bonds and they are alkanes. And unsaturated, there is a double bond, which means it is alkenes. So our test is we add bromine water. Bromine water is orange. And with alkanes, it stays orange. No reaction. So don't write it goes orange, you don't get a mark for that. It is orange, and with alkanes it stays the same, stays orange. With alkenes, it decolorizes. Don't say it goes colorless, don't say it goes clear. It decolorizes. Right. Okay, so back to today's lesson. So polymers, what are they? What are their properties and uses? So the very first question, what is a polymer? So a polymer is a molecule with a high MR, remember MR stands for relative molecular mass, relative formula mass, so a high MR made of repeating units. So a polymer is a molecule with a high MR made of repeating units. That's the definition of a polymer. These repeating units have a name. So these repeating units are called monomers. Monomers. Okay? So poly, if you think in maths, like a polygon. So poly means many. A polygon is a many-sided shape. So poly means many. Mono means one. So we've got, meet Jeff. Here's Jeff. Jeff has a monobrow. Mono means one. He's got one eyebrow, a monobrow. So a monomer, one. Polymer, many. So a polymer is made of many monomers. I'm going to show you one as an example. It's made of loads, right? And because these molecules are massive, huge, long chains, that's why they've got such a high MR, because they're made of loads and loads and loads of these things. They, you know, virtually carry on forever, right? So I'm going to start with a nice simple one. So I'm going to draw you ethene. Ethene. So ethene, we've got 2 carbons with a double bond. Right, we've got hydrogen and hydrogen, hydrogen and hydrogen. That is our monomer for this one. I'm going to draw a couple more so that you can kind of see. I'm not going to draw thousands because the video would be hours long and nobody would watch it. But I'm going to draw you another ethene here. And another one over here. Okay, so we've got 3 monomers. And what happens is the double bonds break. So the double bonds all break. This is a polymerization reaction. Polymerization. So a polymerization reaction because we're making a polymer, right? So these double bonds break. And remember, this is just an example. There would be thousands of these carrying on, but I'm only just drawing it for 3. So if you look, the double bonds are broken, and then all the carbons, this one, they all want to have 4 bonds still, but they've all only got 3 bonds. So what happens is they join together and form a massive long chain. So we had lots of ethene, but this isn't ethene anymore. This is now called polyethene, or as the average layman on the street calls it, polythene. So a polythene bag, like a carrier bag, is made of this. So polythene is an abbreviation of polyethene. So polyethene, poly means many, lots of ethene. So I've only drawn 3 here, but this would carry on and on forever. So those double bonds split and join together, massive, huge, long chain. To draw this obviously can be quite involved and take a little while. So there's a, knowing that scientists are lazy, right? There's a nice little shortcut we've got when we draw this. So how we would draw it. So we have our monomer. I'll draw ethene again. H, 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 H. So that is our monomer. And then, you know, like in maths, when you've got a series that you've got to work out, and it's like the nth term. So if I said we have got n of these, so not, you know, that's just a number, right? So I could write like 8, but we write n for the nth term. So we've got n of these, and then when it reacts, it forms C, C, H, 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 H. But these have only got 3 bonds, so they go wider than that. And then we draw some brackets again. And it's really important that you have these bonds going through the brackets. And then, crucial random mistake, I shouldn't have put the end down there. Over this side, the end goes in front. So I've said I've got n lots of these. So I've got n lots of that. And down here, it goes at the bottom. Because this is like saying, if I had 3 lots of ethene, I'd have a chain here that would be 3 long. If I had 1500 lots of ethene, this chain would repeat 1500 times. Apologies for the error at the start. Right, so this is our monomer, this is our polymer. So ethene and polyethene. Hopefully that seems reasonable. Sometimes on an exam you might get asked to draw. Oh, we've got an interruption. Right, Alfie, off you go. Right, special guest appearance. So you might get asked to draw a polymer made from 3 monomers of ethene. So 3 monomers of ethene. Draw that polymer. So I want you to pause the video and have a go now. I'm going to start the video again when our Stegosaurus timer has gone past. So make sure you've paused it, because this probably isn't enough time to do it. Okay, so 3 monomers. So we've got 2 carbons in there, but we want 3 monomers of it. So you've got 1, 2, 3. These should have double bonds, right? But I'm just going to do it a bit quicker because I'm going to say they've already broken. Let's join those together, and then you just put the hydrogens on. So if we added the H's onto the top and bottom, so that would be, I'm not going to make you sit and watch me draw those H's, but if they all had H's on, that would be our polymer that's made of 3 monomers. But this is the standard way of drawing them. I'm just going to check my notes to make sure that I haven't skipped anything for those. Right, the type of reaction that this is, because there's a couple of different types of polymerization reactions. This is called an addition reaction. I think we talked about this earlier on, where, you know, an addition reaction, you're adding something in. An elimination reaction, you're removing something. A substitution reaction, you're substituting one thing in, you're swapping it. This is an addition reaction because you're literally adding stuff together. So this is addition, more specifically, it is addition polymerization. So we've got ethene turning into polyethene. Now there's 3 additional polymers you need to know about. They're pretty straightforward. So just show you the next one. So we've got C, double bond to C. I'm going to draw this in 2 different ways. The way that you're most familiar with, first of all. Right, if you could just pause the video and try and name this. So pause the video and try and name that one. So I'll give you guys a few seconds. Okay, so hopefully you've worked out that this is 3 carbons, so it's pro, and it's got double bond, so it's ene. So we've got propene. So if you've got propene, just going to draw this in a slightly simpler way. This is CH3, yeah? So I could put it, instead of coming out the side, I could put it coming out the top here and just put CH3. That is still propene. The chain is 1, 2, 3 carbons long. Just makes it a little bit simpler and easier to draw. And so if that's propene, and we had N of them, over here we draw it very similar, but the double bonds just split open. So we'd have H, CH3, H, H. We stick our brackets on, we make sure these go out of the brackets, and we put an N there, and that is polypropene. Polypropene. Just to show you an example of this, if we had to draw the repeating units of this, I'll just draw a few on there. Say it was carrying on. So the bottom would be, if you look, if this was repeating, so the bottom would be H, H, H. The bottom is just all H's, right? And then the top, if you look, it's going to go H and then CH3. H, CH3. So the next one would be H and then CH3, and then H and then CH3, and so on and so on and so on. So you've got your monomer. This is one way of drawing it. This drawing, H, CH3, H, and so on and so on. This drawing is a sort of a longer version of that. Hopefully you can see, if we made that repeat over and over again, you'd end up with the bottom one. So your first one was polyethene, so ethene going to polyethene. Then we've got propene going to polypropene. Right, the next one that we're going to do is called chloroethene. So for chloroethene, we draw ethene, 2 carbons with a double bond, and it's got a chlorine on it. Doesn't matter where we put it, I'll put it on the top here, but it could be any of the others. It just means one of the hydrogens has been replaced by a chlorine, because it was chloroethene. So I'll draw my brackets around it. We've got N of those. So we're going to end up with, I'll break the double bond, so we've got 2 carbons. That one's still the H, the bottom 2 are still the H's, and the top one is going to be the Cl. Do our brackets for our repeating units, make sure the bonds stick out the side of the brackets, and draw an N down there. So this one is Polychloroethylene. That's the technical name for it. It's got an old-fashioned name which has kind of stuck in modern society. So if you're talking about it from a chemist's point of view, we would always call this polychloroethene because it's come from chloroethene. This used to have a different name. This used to be called, I can't spell properly, vinyl chloride, which would make this polyvinyl chloride, which gets abbreviated to PVC. So PVC, polyvinyl chloride, is the same thing as polychloroethene. So if you've got PVC windows at home, like the plastic framed windows, or guttering, things like that, that's made of this polymer. If you remember, it's not one of the ones you need to know, so I'm not going to draw it, but in primary school, that glue that you use all the time, PVA glue, is a polymer. It comes from, the monomer is vinyl acetate. So when you make it into a polymer, it's polyvinyl acetate. So that's what PVA glue is. So what I would like you to do is to have a go at drawing 3 repeating units of this. So draw a polymer at the bottom for 3 repeating units. So pause the video and have a go at doing that. Okay, so your 3 repeating units should have looked like 1, 2, 3, 4, 5, 6. 6 of those, because if we're drawing it 3 times, so 3 lots 2 would be 6. You know, we need to carry on both sides. The bottom will all be H's, and the top would be a H, and then a Cl, and then a H, and then a Cl, H, Cl. Okay, so polychloroethene. So we've got ethene going to polyethene. We have got propene going to polypropene, and now we've got chloroethene going to polychloroethene. So there is one more that you need to do. Just going to start backwards for this one for a second. So I'm going to draw 4 repeating units. Actually 3, because it's just quicker. Right, well, no, 4. Said 4, let's do 4. Right, carry that on there and there. And I'm going to put F, 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 F. This is a skill you need to be able to have. If you get given a polymer, because they might give you an unfamiliar one, if they give you a monomer, you need to be able to draw the polymer. And if they give you the polymer, you need to work out what the monomer was. So here, I've given you 4 repeating units of the polymer. I'd like you to have a go at drawing the monomer. So if you want to pause the video and then have a go at drawing the monomer. So the monomer for this one, you should have worked out, it would be 2 carbons. You would have F's at the bottom for fluorine, F's at the top for fluorine, and the bit which you might have been caught out by, don't forget, you need to have a double bond there. So this, what is this called, I hear you asking? Well, I don't hear you asking because this is a recorded video, but this is Tetrafluoroethylene. So it's ethene because it's like for 2 carbons, ene because it's got the double bond. Tetra means 4. Like, it's not a commonly, you know, a tetrahedral shape has got 4 sides. If you buy a Tetra pack of orange juice in the supermarket, it's got 4 cartons of orange juice in it. Tetra means 4, so it's literally 4 fluorine, fluoro for fluorine, 4 fluorines ethene. So we've got 4 fluorines on ethene. Doing this the way we've done the others, we've got our brackets there, we've got N of those, and the polymer for that one. So I, you know, did draw that out. At the bottom would be the long way of drawing it, but the quick way of drawing it, we've broken the double bond. We've got fluorines at the top, fluorines at the bottom. Got our brackets to show it repeats. Don't forget to draw the bonds going through the brackets, and then that repeats N times. So this is a bit of a mouthful. It is called Polytetrafluoroethene. Polytetrafluoroethene. This one gets abbreviated PTFE. Polytetrafluoroethene. This does have a trademark. It is known internationally as Teflon. Teflon, those non-stick pans, non-stick saucepans, things like that. And we'll talk about the uses in a second. This is called polytetrafluoroethane. It's known as Teflon. In an exam though, don't call it Teflon, call it PTFE or polytetrafluoroethane. So it's non-stick. Just quick check the notes again. So we've gone over all of those. You need to be able to work out, we've talked about this, if they gave you a unfamiliar polymer, you need to be able to work out the monomer, or vice versa. I'm going to just talk about the uses for these now. So if I do this, I'm going to just do a quick table. Hopefully you've been taking notes. I would recommend doing that. So a quick table. So we're going to have the polymer, the properties, and the uses. Just draw on the table, rub that out. Right, so first polymer we looked at was polyethene, and the properties of polyethene: it's flexible, it's cheap. It's not really a traditional property, but it's, you know, it's flexible, it's cheap, and you can make it into thin films if you wanted to. So its uses: it's used for carrier bags, like your water bottles and like bottles of fizzy drinks and stuff. Like those disposable bottles, they tend to be made of polyethene. Food wrap like cling film, that sort of stuff. Food wrap. Those are all the uses of polyethene. So the next one was polypropylene. So for polypropylene, it's flexible, it's very strong, and it resists shattering. Doesn't mean you can't shatter it, but it does mean it tends to, it's more difficult to do. Resists shattering. So it gets used for buckets, like plastic buckets, bowls. You can make ropes out of it. You can make carpets out of it. Those sorts of things. So those, you know, with all of them, properties linked directly to the uses. So the next one we have got polychloroethylene. So that's our PVC. It's really tough. Really quite strong. So it's tough. It's an electrical insulator. Electrical insulator. You can make it hard or you can make it flexible. So those two link, these link directly into the to the uses. Because it's so tough and you can make it really hard, that's where it's used for window frames. That does say frames, I promise. Window frames, or guttering, or plastic pipes. So that is the hard one. If you make it flexible, the fact it's flexible, an electrical insulator, and it's still tough, is where it's used for the insulation around electrical cables. So if you think of your cable for like a phone charger or an extension lead or anything like that, you want it to be flexible, you want to make sure it doesn't conduct electricity, but you also need it to be quite hard, quite tough and resistant to damage. So insulation for cables. And then the last one we've got, which is PTFE, I won't write the full name out here, Polytetrafluoroethylene. So the properties, it is very slippery. So it's slippery and it is chemically unreactive. Chemically unreactive. So it gets used for non-stick pans. They also make sort of industrial carpet or industrial clothes out of it. So, you know, like somebody wearing chef whites in like a formal kitchen, they all can have clothes made out of PTFE. So then if you spilt like tomato sauce or tomato whatever it was, pasta sauce all over it, you can literally just pour water on it and it rinses right off. There's a few other YouTube videos, I'm not going to link to them, but there's other YouTube videos so you can look and watch that happen. Somebody literally pours tomato ketchup all over himself, all over his beautiful white chef clothes, and then just with a cup of water it just rinses right off. Or industrial carpets, so like carpets in a shopping centre or something like that, where you want to be able to clean them really easily, might be made of those. But in terms of what you want for your exam, go with non-stick pans, because of the slippery part, but chemically unreactive. They use them for storing, making containers in a lab. So most of the chemical containers in the science prep room, things like that, are made of PTFE, because then the things you're storing in them don't react with it. Right, just pause it there in case you wanted to jot some of those down. And then final part for today, there's just a couple of other polymers that you need to know about. So you've learned about this one in biology, DNA. So DNA is a polymer, and it's made from 4 monomers, for 4 types of monomers, not just 4, because they repeat a lot, right? 4 monomers, and those monomers are nucleotides. For chemistry, you don't need to know the name of them. For biology, you've probably learnt them, you know, adenine, thymine, cytosine and guanine, you know, ATCG. But all you need to know is, for chemistry, DNA is a polymer made of 4 monomers, and the monomers are nucleotides. You need to know that starch is a polymer. You've come across this in biology as well, hopefully. Starch is a polymer, and the monomer is sugars. And then the other one is proteins. So in biology, you might have learned about protein synthesis. And proteins are made of amino acids. So these are polymers too. This is all you need to know about them. You don't need to know any more detail. And the sort of thing you might get asked in the exam, you know, 1-mark question, what sort of polymer do amino acids make?